Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry math teacher. And everybody, let me know in the chat box if I'm clearly visible and audible to all of you or not. Yes, we have started the live session, guys. Very good afternoon. Not good afternoon, actually, it's good evening. Very good evening, everyone. So, how are you all? So, guys, physical chemistry of class 12th we have already completed, right? If you have not gone through that, go and watch the lectures of solution, electrochemistry, and chemical kinetics. In detail lectures we have completed for that, along with the previous year questions. Okay. So now we are left with inorganic and organic chemistry part. In inorganic chemistry, you hardly have two chapters, that is DNF block and coordination compounds, right? So we are going to start today with DNF block. And one important thing here, DNF block, we will learn it 2 times, okay? I'll tell you how. If you go through today, like this series, hardly in 3 to 4 classes, I'll be done with this DNF block, right? Now, in this DNF block, there is too much information, right? So that's why I'm not going to take like very lengthy lectures of this. Otherwise, it will be very difficult for you to learn everything. On daily basis, you have to revise, like literally revise. Let's say my class is today, my class will be 3-4 days after this, then you have to revise it yourself as well, because inorganic chemistry is firstly understanding, then revision. Now, ma'am, what about NCRT of DNF block? Okay, for that, what we will do, and if you follow this, then I can genuinely say that be it JEE Mains, JEE Advanced, any exam of chemistry where you have DNF block, I can guarantee you will have full marks from DNF block, right? But because DNF block NCRT is in depth, right? You have to follow the steps, right? So firstly, you will go through DNF block through my lectures. Second, you will try to understand it yourself from your NCRT. Okay. So today in the Telegram group, after the end of this session, I'm going to post that what are the pages that you have to read. In the Telegram group, I'll post that, right? Vedantu J English Telegram group. So there you have 3-4 days, go through those pages. Maybe some part you will be able to understand, maybe some part you won't be able to understand. Don't worry. Mark what you're not able to understand, right? Because then after, let's say, 15 days or so, when we'll complete with coordination compounds as well, I'll again start DNF block from NCRT. But in that, I'm not going to cover these basics that I'm going to cover here, right? I'll be strictly jumping to the NCRT lines because they are very complicated. I'll try to make it easy for you. I'll be not again starting with DNF block because both of the things will be connected to each other. So that's how I teach inorganic chemistry. That's how I teach block chemistry, right? If you follow this sequence, trust me, you will get full marks from block chemistry. And P block also I'll teach you in the similar manner, but that will be in the class 11 section. Okay. Yes, everybody. We will be taking P block, right? Right now, I'm not focusing on P block. There is some reason behind that. See, I would have focused on D block in the end. But why I have to teach you D block, there is a reason behind that. There is a reason for everything that I'm doing here, right? Why I have to teach D block here is because I want to teach you coordination compounds. Now, coordination compounds is not at all cramming based. But if you understand DNF block, then coordination compounds is interlinked to DNF block, right? It will become easy for you to understand coordination compounds. That's why I am teaching you DNF block before. Otherwise, these exceptions, all these things, form, in my opinion, firstly, you should, like after this completion of coordination compounds, we will start with organic chemistry because that is more on the understanding part, right? P block we'll see. Aram se, don't worry about that. Aram se will see that like maybe October something. I'll give you full-fledged 6-7 lectures of P block, right? So that it also stays in your head after 2 months. If I teach you now, after 4 months, nothing you will remember. You'll be like, ma'am, what? Right? So that's the reason. Okay? Yes, everybody. So, shall I start with the lecture, everybody? If you're ready for the class, then let me know. Ma'am, do coordination compounds. After this, we are going to do coordination compounds only. Don't worry about that. Right? Okay. Yes. So, oh. God, why these things are happening in my class only, huh? Chal. Now let's start with DNF block, right? So I have some very interesting mnemonics for you. If you have some really, really interesting mnemonics, then you can always let me know in your regional language, right? For mnemonics, one thing is please try to learn it in your regional language, right? The language that you're very, very easy in, right? You think that, ma'am, you are giving mnemonics in English. This is for that audience who wants to remember in English, right? You have like Hindi, English, Marathi, Telugu, whatever language you love, right? Whatever is your regional language, you feel comfortable in, learn mnemonics in that one only. Try to make mnemonics yourself. That you will remember for a longer time rather than the mnemonics that I will give, right? That's a simple thing, right? Because see, I'll give mnemonics based on what I think will be useful for you, right? But you know what is happening in your life, right? So let's start with this. These are the students who are doing their homework and appreciating me. Thank you so much for that. Okay, now let's start with this one, right, guys? So this is your periodic table, right? Now, one rule of block chemistry is that tomorrow you're going to go to the market, you're going to purchase one periodic table, modern periodic table, stick it on your wall. You want to be pro in block chemistry, please stick it on your wall. Now, how it will help? It will help. Trust me, it will help, right? It will help, right? You just need to paste it, a good colorful periodic table in your room, in your wall, on your wall, right? Okay. Now, if you go through this periodic table, what are the sections that we have? Ma'am, this is S block, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Can you tell me what are these 18 things called? 18 columns. What are these called? These are called the groups, right? And what you have here, 1, 2, 3, 4, 5, 6, 7. These are called the periods, right? And if you divide it here, there are going to be 18 groups and 7 periods, right? First two groups are under S block. Earlier you used to have S block, like back then students used to learn S block in detail, but now it's only in the JEE Advanced syllabus, right? So you'll understand that when we are focusing on JEE Advanced, right? And if you talk about this is what is D block, right? From group 3 to 12 is D block and 13 to 18 is P block, right? Now, what you have in your syllabus, you have P block, full-fledged in detail. You have F block, not so many questions are asked, but based on electronic configuration, they ask you. You have D block, and that too, this 3D series is very, very important for you. That's from, this is from where they ask you the questions, okay? So now, what we are going to focus in this chapter is D and F block, right? For that, you have to understand that why they are called D block, why these are called S block, these are called D block, these are called P block, these are called F block. And second question is, ma'am, why it's not like 1, 2, 3, 4, 5, 6, 7, 8, 9? Ma'am, why it is not 8, 9 here? Reason, right? Here, reason is, if you see this here, from this is your lanthanum, this is your actinium. Okay? Lanthanum and actinium are the member of group 3. This is group 3. In group 3, you have lanthanum, you have actinium. Right? Now, after lanthanum, you have these elements. That is called lanthanoids. Okay? After actinium, you have these elements. They are called actinoids, right? Okay. Now, that is the reason it's like they are in middle of this thing, okay? These lanthanoids are somewhat here. These actinoids are somewhat here, right? And why we have made it like this? Because we want to match the properties here, right? From here, we are, okay, let's understand one more thing. Why S block is called S block? What is the reason, everybody? Try to give me the reason in the chat box. Why S block is called S block? Right? Okay. Yes. Yes, students, I am looking for your answers in the chat box. Yes. Why the F block is called F block? Wait a minute. Let me see what is the brightness here. Right. Check. Okay. Let me also make it less blurry. Okay. Chal. I think now it's fine. Okay. Now let's see this. Why you have F block as F block? Why you have S block as F block? Yes, because of the outermost electron. Okay. So in here, outermost electron is in S. Here, outermost electron is in D. Here, outermost electron is in P. And in these elements, the outermost electron, the last electron was in F. That's why this is S, this is D, this is P, and this is called F block, right? And our focus is entirely going to be D and F block in this chapter. We are not going to talk about S block and P block in this chapter, right? Okay, major chunk is D block and that too 3D series. Okay, so let's understand D block elements, right? To understand the elements in which last differentiating electron is in D orbital, that is belonging to D block, right? Now, if you talk about from group number 3 to group number 12 are your D block elements, right? You know, these are also called as transition elements. Can you tell me why they are called transition elements? Because S block is metallic in nature, right? And if you see, this is P block, right? We are moving towards more non-metals here. The properties, let's say this is electropositive in nature, this is electronegative in nature. So we are moving transition towards P block here, right? S block are like S block and P block have entirely different properties, right? And this D block serves as a transition phase, right? That's why they are called as transition elements, right? And why F block is called inner transition element? Because it is somewhat inner of the transition elements, right? Now, the question that arises, ma'am, if you talk about the transition elements, right? Okay, I'm talking about transition element. These are called the transition element. Now, the question is, ma'am, are all the D block elements transition elements? For that, you have to see one more definition that is more applicable in this based on the electronic configuration. So it says that the transition element may also be defined as element which has partially filled D orbitals. Means if you have D0 or you have D10, then it's not a transition element. Not a transition element. Not a transition element. That means in transition elements, it can be D1, D2, D3, D4, D5, D6, D7, 8, D8, D9. But if you have D10, if you have D0, then it's not a transition elements, right? So there are some examples for it. Why are they called transition element? That I have already told you. Because there is transition from S block to P block, right? And in between that transition, the elements that we have are called transition elements, right? Now, next is, ma'am, are all the elements transition elements? Anybody in the chat box, are there some exceptions towards it? Not exceptions actually, they are not just fitting in the definition of transition elements. So, tell me in the chat box, students, right? Yes, very good, very good. Zinc, 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 very good. Zinc, zinc, cadmium, mercury. These are your non-transition elements. Zinc, cadmium, mercury. Now you will ask me why. See, that lies in their electronic configuration. That also I will teach you, right? Because zinc, for now, what you can understand, zinc has D10. All of them has D10 electronic configuration. Not this has 3D, this has 4D, this has 5D. I'll tell you how. This is your 3D. This is belonging to 4D. This is 5D. This is 6D. Okay? First transition series, you have 3D orbitals. Second transition series, you have 4D orbital. Third transition series, you have 5D orbital. Fourth transition series, you have 6D orbitals, right? So when I talk about that zinc, cadmium and mercury, and we are not going to talk about 6D transition series, we are not even talking about 6D series. We are majorly focusing on 3D, then 4D and 5D in comparisons, right? 6D, we are never going to learn about 6D, right? So take a chill pill on 6D. You have to remember that this is 3D, this is 4D, and this is 5D. Now, this is zinc, this is cadmium, this is mercury. Are you able to see this, guys? This is zinc, cadmium, and mercury here, right? All of them are, I'm just randomly telling you here, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when you start, see in D orbital, how many electrons you can have? 10 maximum. You have 5 boxes for D orbital. So maximum 10 electrons you can fill here, right? So now it is filling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these always have, even in their even in their ground state, they are 3D10, right? So they have fully filled D block, right? That is the reason they are called non-transition elements, right? Because they have D10 in ground state. That means they don't need to be excited to have D10 in their ground state and even in their excited state. In their excited state as well, they are D10 only. Now, ma'am, what is this excited state? See, if you talk about this is D, right? Let's say 1 electron is there. This we have learned in structure of atom. When it absorbs energy, it will move to the higher shell. This is what electron actually do, right? It absorbs energy, it moves to the higher shell, it emits energy, it again back to the lower shell. This is what it does, right? So that is in the excited state, when it has some kind of energy, right? It's like when you're sitting bored, you are sitting alone, you're thinking about this and that, you're not able to study, you're very, very, very bored of life, right? This is that state. In ground and like ground state and excited state is, even if you ask them, there are some students, when it's their birthday also, they are very excited, but still they will study. These kind of students they are, right? It's birthday, it's Diwali, it's Holi, it's whatever is the function, right? It's Dussehra, whatever, it's New Year, whatever is the function, it's their birthday, whatever happens, they are always in the stable configuration, that is D10. Okay? Yes, everybody? D0, D10 containing elements doesn't belong. This is the definition, right? This is the definition given by scientists, that whom they will consider as transition elements. Okay? They sit together, they were like, okay, let's make transition elements. What can we say transition elements? Then they all thought that transition elements will be the one which has partially filled D orbital. That is transition element. That's why all the D block elements are not transition elements, but all the transition elements are D block elements. You can't say anything which is not in D block is transition element. No. But all the elements in D block are transition elements. That's wrong, because zinc, cadmium, mercury, this belongs to D block, yet it is non-transition element. Right? Okay. Now, next is your position of D block element, and this is very, very, very important. Very important, right? So let's understand that. Now, your focus is entirely going to be on 3D, 4D and 5D series. You should know to which period 3D series belong, 4D series, 5D series belong, what we call them as first transition, second transition, third transition, fourth transition series. So these are the simple names that you should remember for D-block, okay? The full poster of this D-block should be in your head. Copy paste as it is, okay? So now we will understand that how it should be copy pasted in your head. First thing, students, that is in your fourth period. This is very confusing and trust me on that. When exam, they ask you fourth period, students get confused. Fourth period was 4D series. No, fourth period is 3D series. Okay? Fourth period is your 3D series. That's how periodic table is made. Right? Fourth period is 3D series. And that is, I can even write it here. Fourth period is 3D series. Right? Where 3D elements, 3D orbital is filled. This is 4D. This is 5D. And this is 6D series. Right? And fourth period is first transition series, then you have second, then you have third, then you have fourth transition series. Now, everybody, I'll ask you one question here. Let me see if you can answer this or not. Tell me, 5D series belongs to which period? Which period? This is a quick question so that you can side by side answer me. And if you're sleeping in the class, then you can, just wake up in the class, right? Like, ma'am, very good, ma'am. Very, very, very nice, ma'am. I'm very good sleep I'm having. You talk about DNF block, it's very nice, ma'am. It's so boring that I'm having very good sleep. It's not like that. I know it's tough. Yeah. I know it's tough. Inorganic chemistry is interesting, but when it comes to learning these things, that becomes tough. So that's why understanding it, right, then revising it again and again and again and again, how many times, I don't know. 5, 6, 7 times, so you should have gone through your NCERT, that's for sure, before the exam, right? Okay, so 6th period, yes. Is it belonging to 6th period? Yes, right? So, what I asked you, 5D series, okay? So, this is your 5D series that is belonging to 6th period, okay? Yes, everybody. 3D, just remember 3D is belonging to 4th period. That's it. It is the first transition series. That's it. Okay. Now, this in fourth period in the 3D series, you have scandium to zinc, ytterbium to cadmium. This is lanthanum to mercury, and this is actinium to the CN, right? This is not in your syllabus. This you don't have to learn. 3D, 4D, 5D comparison is there in your syllabus. For sure, they can ask you question based on comparisons, and direct question. If you know the question, you will be able to answer this within seconds. If you don't know, then you don't know. As simple as that. Right? So now, firstly, we have to remember these elements. Right? We know that where they are positioned in the P block. This is where they are positioned. Okay, I'll just show you again. This is 1, 2, 3, 4th period. This is where these are positioned in the P block, in the periodic table. Right? Now, next thing is, let's learn about its electronic configuration. General electronic configuration of D block elements is, it can be written in two ways. One is N-1 D. Now, who will tell me what is N-1? Let's see. Who will tell me? N-1 D, 1 to 10. This is NS 1 to 2, except platinum, which is having 5S0, which is having 0 in its S, in its outermost S subshell. Okay, or it is also written as N-1 D, 1 to 10, 1, 2, 3, 4, anything it can be, right? NS0 to 2. Now this 0 we are saying for flooded. Now in some books it is written like this, in your NCRT it is written like this. Okay? In your NCRT it's written like this, in other books it is written like this as well. So now it's not like this is wrong, this is right. Both are correct because both are telling the same thing only. Both are saying here they are not taking NS0 as exception, right? Here they are taking NS0 as exception because that is the only element in entire D orbital which has, in D block, which has S orbital as 0. Okay, yes, very good, very good, very good, beta, very good, seriously studies, very good, Supriya, very good, Rohit. That is called penultimate shell. Okay, this thing is called penultimate shell. Now, if you see this here, if you compare this here, fourth period means it will be 4s. Fifth period means it will be 5s, it will be 6s, it will be 7s, right? And D is the penultimate shell to it. That means if this is 4s, this is 4 minus 1, this is 5 minus 1, this is 6 minus 1, this is 7 minus 1. Okay, that's how it is, right? That's how you, in your, from your off-bow principle, that's how the energies are arranged. That's why we have written it like this. If you ask me, ma'am, why you have written it like this, ma'am, why not with 4s you have 4d? Because according to N plus L rule of off-bows, that is how the energy, increasing order of energy. So we have to write it that way only, right? So that's why firstly I completed like the structure of atom, right? That electronic configuration is very important part here, right? So if you have like not gone through electronic configuration, you are someone who is not in class 12th, who is class 11 student, then I would not advise you to watch this lecture because entire inorganic chemistry is based on electronic configuration, right? So first you have to know what is electronic configuration, right? So let's understand, this is the general, this we have already seen, right? Now let's talk about PD is the only D block element that is 0 electron in the S orbital, outermost S orbital. Okay, right? Let's see. Can you see this or not, guys? Can you see this or not? Do let me know. First transition series, that is 3D, first transition series, that is 3D series. Now, firstly, you should learn what exactly how to remember this. Okay? Now, there are various ways to remember this. How do you want to remember it? It's totally your choice. There is no obligation on you that this is Diksha ma'am's trick. You have to remember this. No. Okay? Even I made this from ChatGPT. Okay? So chill, right? So, like whatever you like, right? What if you feel that, ma'am, this is the trick that I can't relate to, change it whatever you like, right? It's your life, your rules, right? So you think that this is not relatable to me, mnemonic is, ma'am, even more difficult than the original one, change it according to yourself, in your language, like the way you talk, whatever you feel like. Okay, so let's talk about this. Here it is, sad Tanvi viewed crushed memories for constant nostalgic cry zones. Okay? So Tanvi was very sad. Tanvi was like just went through breakup. Tanvi was like what to do, right? Tanvi was stalking his ex, stalking what she was going through. Crushed memories. His crush, right? Everyone has a crush. Mine is Vicky Kaushal, right? So crushed memories for constant nostalgia cry zones. Then she's crying in the corner. Oh my God, what was my fault? Blah, blah, blah. Right? So this and that. So that is how I remember this. Ma'am, how do you remember this? My way is very different. I remember this by Saktiv Karman Piko Niku Jan. Okay? That's how I remember. You can remember this by other way also, like whatever you like. But this series should be on your tips. Like on your tips means on your tips, right? So This is 21, this is 22, 23, 24, 25, 26, 27, 28, 29, 30. And now, if you don't know how to do electronic configuration of 3D series, forget about coordination compounds, because coordination compound theories are based on entire coordination chemistry is based on the 3D series electronic configuration, right? So let's firstly understand the electronic configuration in just right. Same taught by my teacher, yeah, same taught by my teacher. So my teacher also taught me Saktiv Karman Fikunikojan, so that's how I remember, right? I don't know how I learned this. I have no idea. He was just stating it again and again when he was teaching us Saktiv Karman Fikunikojan. That's how I remember, right? Okay. So now that's why I'm saying mnemonics are never, you should never copy paste it, right? Okay. Either you remember what you remember from the first time, that is your mnemonic. You have your own mnemonic, however stupid it can be, remember it, right? Now, let's understand the electronic configuration of 3D series. Okay, that is a must thing. Electronic configuration of 3D series. 3D series. Okay. Now, guys, for this, what you have to do is we will talk about exceptional also. Firstly, just write Saktiv Karman Fikonikojan. So I'll just draw these lines here. That is the first one is your okay. I hope so I'm able to draw a straight line because I'm never able to do it, right? Chal. Now let's do this. Okay. This is the atomic number that you have here. Okay. Here it is. Saktiv Karman Fikonikojan. Okay. Right. After that, this is nothing but this is, I'll just write it here only. Wait a minute. Okay. What you have to do is, this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Trust me, beta, some around 3 to 4 questions you can see which are based on this particular electronic configuration only. In your syllabus, no other electronic configuration is as important as this, right? So, if you see this scandium, see, it will be, because this is belonging to 3D, so there will be two things. One is 4s and then there will be 3D. Now, can you tell me which is filled first? You have 3D, you have 4s, and before this you have argon. Okay, this n plus L is 3 plus 2, that is 5. And here it is 4 plus 0, that is 4. Okay? So, can I say that 4s will be filled first, then you will have 3D? Right? That's how it will be written. N plus L rule, I just applied it here. Right? So, 4s is N plus L is 4. 3D, N plus L is 5. Right? So, that means increasing order. That means 4s will be filled first. So, you can write argon everywhere. Argon, 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 right? Now, you can write 4s will be filled firstly, na? Yes. 4s, 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 right? Acha, here what has happened now? This I need to, oh, ठीक है. हाँ, I think now it's better. Off भी आ गया. ठीक है. Now write down 3D, 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 3D. Now I'll tell you simple thing, okay? 3D, 3D, 3D. Now, see, this is atomic number 2, 1, write 2, 1, 2, 2, 2, 2, 2, 3, 2, 3, 2, 4, 2, 4, 2, 5, 2, 5, 2, 6, 2, 6, 2, 7, 2, 7, 2, 8, 2, 8, 2, 9, 2, 9, 3, 0, 3, 0. Now see this thing. Tell me one thing. Is there a possibility that there are 3 electrons in 4s? No, ma'am. Right? So what it will be? It will be definitely, because argon is nothing but it's 18. Actually, what we are doing, 18 electrons here, then 19, 20, 21. 18, 19, 20, 21, 22. 18, 19, 20, 21, 22, 23. So here it will be 18, 19, 20 and 10 electrons will be here. Right? Now, there is one exception as well. 2 exceptions as well. These exceptions are over here. That is chromium, right? That is chromium. You can see this here, right? Okay, so what I'll do here. This is chromium is the exception and copper is the exception. So what is the exception, everybody? What is the exception? The exception is, it is going to be, the exception is, it is going to be argon, right? Then it is going to be, I don't have space here. Okay? Sure. Better. Now, this is going to be argon. Now, whenever someone is like, you are going to be stable, like, you are making me stable by giving me JEE seat, by giving me IIT, I want to be stable. You have to give 5,000 rupees extra for that. Why? That is my kharcha pani, right? It will be like, okay, 5,000 rupees extra they are asking. If I am getting IIT seat, IIT Bombay seat, I can give them, right? That's how your thought will be, right? 5,000, 5 crore package, you can manage, right? So here, here this is argon. Now, if 3D be like, bro, can you give me 1 electron? Why? Because I can be 3D5. If I am 3D5, I am into a very stable configuration. I am half filled. Similarly happens with copper. Copper be like, 4s, can you give me your 1 electron? 1 electron will jump here. It will be 4s1 here. And that's how you have these 2 exceptional electronic configurations. Okay? Yes, everybody. Half filled and fully stable are very, very stable. Ma'am, okay. Anirudh, yes, it's possible if your base is clear. Okay? It's definitely, see, anything is possible in this world, right? So if your base is good and if you're confident enough to work hard in next 6 months, then surely that is possible. But for that, I already posted a planner for droppers in 12th freshers, so you can go and watch that video. According to that planner, if you are able to complete all the chapters, then yes, it's possible, right? Okay, yes. So that is clear, right? Now there is no problem in that. Saktiv Karman Fikunikojan, right? Now this electronic configuration has too many uses that we will see. Now about 4D and 5D series, as such electronic configuration is not asked in any other chapter, but right now they are focusing on even lanthanoids electronic configuration, even actinoids electronic configuration, right? So we have to go through that. So first one is, this is very, very important. This is very important, that is platinum, that is 5s. Why? Because can you see over here, it's the only element that has S0. Here, can you see anyone has S0? No, ma'am. Here, can you see anyone has, this is 5s, okay? Only here it is 0, right? Only here it is 0. And can you see over here? Can you see over here? Anyone has S0? No. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, right? 1, 2, nothing, 0. So that forms the exceptional electronic configuration. That's why this is highly important for you. That is 5 as S0, 4D10. This is the electronic configuration that becomes extremely important for you, right? Now talking about 4D series, how to remember this, right? You zoom near my tech review reel, posted a comment daily, right? Posted a comment daily. है ना? That's chat GPT, that's not me. Right? Okay. I to remember this ऐसे, right? So there is no logic behind how I remember. Right? So you can go through this if you like, if you don't like, it's okay, it's fine. What to do? Right? That's the maximum AI that I can use. I was asking chat GPT, like, why are you giving me these kind of stupid mnemonics? Give me something better. And chat GPT was fourth time he gave me the same reply. And I was like, okay, either I don't know how to ask chat GPT or chat GPT is still learning. Is still getting, chat GPT was like giving me very hi-fi vocabulary. It was like, I was like, bro, like we are like Indians. We don't know this much high vocab. We don't know, right? So please tone it down. ChatGPT is also a risky game, huh? How many of you are actually using ChatGPT for your homework? Like I've been seeing these reels and all that where students are actually solving their questions from ChatGPT. See, one advice like to you guys, it's good, it's really good, right? But sometimes ChatGPT also answers like wrong, right? I have seen that. Some questions ChatGPT is like hallucinating. Like now maybe it's improved, but 1 year back, so it was hallucinating a little bit. I was like, what answer? ChatGPT, I asked them, ChatGPT, the updated syllabus. 5 years back syllabus ChatGPT is giving. I'm like, ChatGPT, what happened to you, yaar? I was actually relying on you. Then I got scared. I was like, I don't want to rely on ChatGPT for these things at least. Right? Well, okay. Now that is simple. है ना? Now let's talk about next thing. Now this is also the electronic configuration of 5D series. This is how you can learn it. Heartfelt texts were read once, ignored promptly after unfollowing her. Right? Okay. So that's how you can remember this as well. Right? So how do I remember is very weird thing. La hafta, wo re, उससे सॉरी वो रे उससे ऐसे पिटेगा और होगा. I don't know what is this, but it is that. Okay, that's how I remember, right? La hafta. Like someone is asking you for hafta. Some Don is asking you for hafta. La hafta वो रे उससे इतना पिटेगा और होगा. Whatever you like. Okay? Now, where we are at this point. Now, beta, I'm going to tell you some very, very important exceptional electronic configurations that you must remember. Okay? These are the electronic configurations that you should remember. Okay? Because these are the exceptional electronic configuration. If you see here, copper, chromium, I have already shown you. Right? Let's talk about see, can you see this here? Oh, can you see this here? It is supposed to be 2 and 3. What exactly it is? 1 and 4. Can you see one electron jumped here? It is not even making it stable. Still it jumped here. That is the exceptional. And this they have asked in your previous year questions. Okay. Molybdenum. Right. They have asked it. Technetium, it should be 1 and 5. But it's getting 1 and 6. Ru, Rh, Pd, Au. Right. So, can you see this here? Technetium, molybdenum, Pd, silver, platinum, gold. Wait a minute. Silver, platinum, gold. Can you see this over here? Platinum, gold, and here you have silver. And here you have silver, that is here. Okay? So all the electronic configuration which does not have 4s2, 3s, 4s2, 5s2, 6s2, they are exceptional. Can you see this over here? Right? Here what we have, chromium, copper, exceptional electronic configuration. Right? Similarly, here we have too many exceptions. Right? 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 0, 10, most exceptional. Then 1, 10. Right? The next is over here what we have, 1, 9, 1, 10. So these are your exceptional electronic configurations that you must remember. Okay, here either S will be 0 or 1. Okay, these are the exceptional electronic configurations. Is that clear to everybody? What you have to remember, right? Yes, everybody. Shall we move ahead? Shall we move ahead? Right? Leave it. I don't want to even look at your comments, right? Just mocking, huh? Just coming here, poking everyone. Huh? Free time we have, ma'am. Sometimes, ma'am, why am I not speaking in Hindi, ma'am? Ma'am, you just said a word of Hindi, ma'am. How can you say one word of Hindi, ma'am? Ma'am, like why you're taking, why you're living, ma'am? Why you're dead, ma'am? Why you're this, ma'am? Why you're that, ma'am? Why this, ma'am? Why that, ma'am? Why? Always why. Never satisfaction, right? Never happy. Sad people, sad Gen Z people. Be happy. Can't you be little bit like happy in your life? So much. What I would say that so much anger is within you that you have to like. You don't even know me. I don't even know you personally. Still, you have to like disturb everyone in the class. So much anger within you. So now, guys, let's see these two things. These are our 3D, 4D, 5D series. Now, let's talk about this one, zinc, cadmium, mercury. So, these three are called volatile metals. Okay? These three are called volatile metals, zinc, cadmium, and mercury. Right? They are called non-transition elements as well. And copper, silver, and gold are called coinage metal because we form coins from them. So, these are the names of these set of metals, right? Now, let's talk about next is the metallic structure. This is given in your NCRT. Now, the question is what exactly is given here, right? Okay, so there is one question to this that I'll answer here, right? I'll just ask you that question over here, right? Wait a minute, in the properties here, right? So, if you see this here, all the transition metals show typical metallic properties like high tensile strength, ductility, malleability, high thermal and electrical conductivity in metallic luster. So we can say these transition metal elements are actually behaving like metals only, right? They are like metals, right? But with the exceptions, very important, zinc, cadmium and mercury and manganese, they have one or more typical metallic structure at normal temperature, right? So if you see this here, zinc, cadmium and mercury, right? Zinc, cadmium and mercury here, right? Then you have manganese, right? Can you see one thing here, guys? Can you see one thing? Which is that thing? Why this table is given to you in the NCRT? See, NCRT is all about decoding. So many of you must have gone through this, isn't it? So many of you must have. How many of you have always ignored this table? You've gone through this multiple times, but you have never thought that what is this X, what they have given you here, right? What this is actually telling you, right? So, anyone of you, anyone, bacha, anyone, Sai, Rupesh, Supriya, yes. Yes, Tarun. Okay. Yes, everybody. No unpaired electron in D. See, this is telling you this. Why you have then manganese? Manganese has the 4s2 3d5 electronic configuration. So this is the experimental data, right? You must have gone through in JEE Advanced, you have solid states, right? So in solid states, what you have is that you need to take care that in solid state, if I'm talking about FCC, HCP, CCP, BCC, all these are certain states that you have. And Tarun, I just want to tell you one thing. If you're still here, right? See why we are teaching you in English, right? Why we are teaching you in English. The reason is we want you to understand. We want every single student out there who is not able to understand Hindi to understand like in your regional language if you have a good content. If you don't have, we are here, right? So that's why we are here. There is no boundary of languages here. You're from north, you're from south, you're from Middle East, doesn't matter. All what matters is, do you want to learn? Do we want to teach? Yes. Right? That's why we are here. We do care for you. That's why we are here. Right? So don't say things like that. Yeah? Don't say that. Right? So students, we know that BCC, HCP, FCC, all these are fixed states in the solid states, right? Now, ma'am, I don't know about it. It's okay, you don't know about it. There are some lattice states that are fixed. But in manganese, sometimes it is BCC, sometimes it's CCP. It's not fixed. In this zinc also it is fluctuating. In cadmium also it's fluctuating. In mercury also it is not having a fixed state here, right? So that means manganese, they have written X here. Here they have written X. Here they have written X. Here they have written X. So this X symbolizes that these elements in the D block, they don't have a proper lattice structure. And that is the reason, with the exception of zinc, cadmium, mercury and manganese, they have one or more typical structures at room temperature. One or more typical structures, right? That is the reason they are not following these proper metallic properties, right? Because of their lattice structures. Understood this thing? Are you able to understand this table, right? Okay. Yes, everybody. Yes, everybody. Very good. Very good. Do let me know. Do let me know in the chat box. Everybody, I'm waiting for your answers in the chat box. Why are you guys discussing pseudo and noble gas configuration? We'll talk about that. We'll talk about that. Right? So transition metals are very hard and have very low volatility. Right? They are very hard. Let's talk about some common metals that you have. Gold, it's hard. Not that hard, but still it's hard. Right? Then you have silver, gold, silver, copper. Right? All these are your transition elements that are very hard and have low volatility, right? They have high melting and boiling point. And this is what is most important point from here. It has high melting point. This is what we are going to discuss here, right? Why now it has such a high melting point? The high melting point of these metals are attributed to involvement of greater number of unpaired electrons in the n-1d orbital, right? So more unpaired electrons. Now, ma'am, what happens when you have more unpaired electrons? More unpaired electrons means more is the bonding. Let's say here you have 4 unpaired electrons, okay? There is some other thing that has 4 unpaired electrons. As such, it doesn't happen like that. I'm just giving you one example. One more atom or something has unpaired electrons, right? So unpaired electrons orbital can overlap with the other unpaired electron, right? They can form a bond, right? So that's why we say that more the number of unpaired electron, more will be the bonding, right? More is going to be the bonding. The simple thing is if someone is single, right? they are going to have more bonding, more crushes will be there in the class, right? More chances will be there, right? So more unpaired, not paired, not in the couple form, right? Not like in one orbital you have 2 electrons, no, right? So here what you have, more unpaired electron, more is the bonding, and more is the bonding. Bonding is very strong. Now can you break it? You and your best friend, right? Very strong bond you have. Now can someone break it, guys? Can someone break it? Tell me. Can someone break it? I want to break your bond. No, you'll be like, ma'am, we are best friends. Like from childhood, we are best friends, ma'am. You can't do anything here, right? So we can't break it. So that will means melting point is going to be high here, right? Nothing will happen. Nothing will happen, right? So more unpaired electrons, more is the bonding, more is the melting point, right? Now, because this n-1 d orbitals, let's talk about the unpaired electrons here, right? Attribute to involvement of greater number of electrons from n-1 d in addition to ns electrons. That's why they have high melting point, right? Now, guys, let's talk about this. You have Sakativa Karamana Piko Niku Jana. Right? So, now tell me one thing. What we had written here, right? This was supposed to be 3D1. This is 3D2. This is 3D3. This is 3D4. This is 3D5. This is 3D5. This is 3D6, right? 3D7, 3D8, copper is 3D10, zinc is 3D10, right? This is what we have. Now, can you tell me the number of unpaired electrons here? 1, 2, 1, 2, 3. How many unpaired electrons? 1, 2, 3, 4, 5, 5, 5, 5, 6. 1, 2, 3, 4, 5. 5, 6. How many unpaired? 4 unpaired electrons, right? So we can write it 4. What about 7? 1, 2, 3, 4, 5, 6, 7. How many unpaired electrons you are left with? 3. Can I write it here? 3. How many unpaired electrons? 1, 2, 3, 4, 5, 6, 7, 8. How many unpaired electrons here? 2 unpaired electrons, right? So can I write it here? 2. 10. Is there any unpaired electron? No, ma'am. No unpaired electron. 0 unpaired electron. 0 unpaired electron, right? Now, we know that more the unpaired electrons, more is the melting point. Less the unpaired electrons, less will be the melting point. So, should it be like this? Increasing, increasing, increasing? Decreasing, decreasing, decreasing? Should it be like this? How many of you agree with this one? How many of you agree with this one? That it should be like this, ma'am. It should be increasing because unpaired electrons are increasing. This here it is maximum, right? After that it is decreasing again. Can I say this is how it will be, right? Okay, yes, everybody. Arsana seriously studies. Pratyush. Then we have Rohit. Yes, everybody. Yes. Arsana, that is in periodic classification. You'll have to watch it, right? So I'll be stick to DNF block only here because otherwise the other students who are watching this, they'll get confused, right? Okay. So now it should be like this, right? But in reality, it's not like this. In reality, you'll be like, DNF block is full of exceptions. You'll start hating it someday, right? But don't worry, I'm here. It will increase, it will decrease, it will increase, it will decrease. Why, ma'am? Why this M kind of peak is there? See, what will happen at manganese, you will see an exception. Manganese, you will see an exception. Yes, inorganic chemistry is full of exception, right? Manganese, you will see an exception. I'll tell you how you will see the exception over here, right? Let me just show you this thing, right? This is 3D, okay? This is 4D, this is 5D, right? Now, understand one thing. Let's just talk about why there is this dip here. Why this exception is over here, right? This exception is over here, right? Now, it was supposed to be like this, right? But it actually dips to this point because originally it has 5 like unpaired electrons, right? So what happens here in the middle of it, right? What happens? It suddenly its melting point will decrease here for manganese, right? That is the exception. Same thing happens with technetium. This is a question of I don't know, previous year question this is, right? So that is manganese has the exception, sudden dip. Technetium has the sudden dip. But in 5D series, you don't have this sudden. This is 3D, 4D, 5D series, you don't have this sudden dip here, right? That is very, very important. It should be like this. It's actually like this. Okay? Where is the dip? Manganese and technetium. There you can see this dip over here. Now, next important thing is, ma'am, why we have 3D, then we have 4D, then we have 5D. Why it is so? In the data, it's like 3D is minimum among 4D, then you have 5D. Why it is so? Why it is so? So, first let me just answer this. You have 3D, then you have 4D, you have 5D. Because Z effective increases in this way. Z effective of D block. Now question is, ma'am, how Z effective is increasing this way? See, if you have gone through periodic classification, you must already know this. If you have not gone through periodic classification, like that is your backlog and you still want to understand it, right? Then don't worry. I'm going to take up periodic classification after structure of atom, right? So you can go through that as well. So that will help you to correlate DNF block with the periodic classification. Okay? Yes? Okay, everybody? Okay. Yes, 5. Why are you even doing 5 previous year questions? I mean, there is no benefit of doing that. I would say from every chapter, pick out just one question and you can do like in total 20 topics and just one question and just pray to God and He can only save you. Okay? So, let's talk about this, right? So why it is so? Because Z effective is increasing down the group in D block. That is the reason, because Z effective is increasing. That is the reason your melting point is increasing. Why? Because metallic bonding depends upon number of unpaired electron, which depends upon the Z effective, right? More the Z effective, more will be the melting point. So that is the reason Z effective is going to be, Z effective is, this is 3D, this is 4D, and this is 5D. And that is the reason melting point is in the same range, that is 3D, 4D, and 5D. Okay, and melting point is very, very important. Now, I'll ask you some questions here that they can ask you from the graph. A dip in 3D series is observed at manganese. Dip in 4D series is observed at technetium, right? Now you have to tell me what is the maximum melting point in 3D series. Maximum melting point in 3D series, in 4D series, in 5D series. Okay? Maximum melting point in 3D series, 4D series, and 5D series. Anyone of you can tell me that? Right? Yes, everybody. Prani, I have already made, right now is the best time. right? I have already made a planner for you, right? If you're a dropper or 12th fresher, you can go through that. That will really, really help you. In detail planner, I have already made, right? So this is maximum melting point for 3D series. Can you see this over here? Chromium. So can I answer chromium? Yes. Maximum melting point for 4D series is molybdenum. So can I write here molybdenum? Yes. Maximum melting point in 5D series is tungsten, right? So that is this one. That's why we use tungsten. Now we use LED filaments, LED bulbs, right? But earlier we used to use tungsten bulbs, right? Because it has very high melting point, right? So that's why even at very high temperature, it was able to give us glow as in not on your face, in the surroundings. It was able to give you light, but not, it was not melted, right? Even at very high temperature, right? Okay, yes. Now that's it. Okay, tell me if you have any problem in this particular thing. This is the graph. These points are very, very important for the graph. And this point is also very important for the graph. That firstly, minimum is 3D, then you have 4D, then you have 5D. These are the graphs. That's how you study the graphs. And that's how they will ask you the questions from the graph. Okay, everybody? Yes, everyone? Everyone here, is that clear? Right? Yes. Whosoever wants to be good in D-block can attend this. Right? So, let me see if you have anything left here. In the series of transition metal, the melting points rise to maximum at 3D, except for anomalous behavior of manganese and technetium, and fall regularly as the atomic number increases. Right? Okay. Now, can you see these exceptions? Everybody, very, very important. See, inorganic chemistry is all about if someone can tell you that these are the things that you need to learn, half of your work is already done, right? And this is work I have already done for you, right? So, if you see this, it is supposed to be zinc, cadmium, mercury. Okay, so I'll just show you this thing here. This is where is zinc? Yes, it is actually not written there. So I'll just write it here only. So I'll just write it here. Right? See, what we have here is, if you talk about 3D, this is belonging to 3D. This is belonging to 4D. This is belonging to 5D. Okay? So these are the exceptions. Right? It is supposed to be, because what I told you, that 3D will be minimum. It is supposed to be like this. So it should be zinc, then cadmium, then mercury. Because the reasoning that we have gave here is that down the group of D block, Z effective is increasing. Because Z effective is increasing, the nuclear attractions are increasing, right? Because someone is more attracted, so they will have more melting point. To break it, it will be very difficult, right? So that's why more attraction means more melting point. But here we can see a different scene altogether, right? So zinc, cadmium and mercury has opposite order here, right? So this is the exception, because this is not correct, okay? This is not correct, this is correct. Similarly, if you see copper, gold, silver, right? If you see this here, let me just, okay, here it is, okay? See this very carefully, it is written. It is not exactly written in your NCERT. Some things are not written in NCERT. So that's why I'm saying that when I'm saying NCERT reading is important, doesn't mean NCERT reading. It means these things, right? These things are important, right? So let's see this. If you see this, this is going, and over here, this is where your 4D series is falling, right? If you see this here, this is nickel, copper, and that's where it is falling. So you can say this is 3D. And 5D series is over here. Can you see this? Can you see which one has more melting point here? Copper has more, then you have gold, then you have silver. But how it is becoming? It is maximum is for 3D, then you have 5D, then you have 4D here. This is the exception. Okay? This is the exception that you have here. Students, are you able to understand? This is the exception. Another exception for this one is, this is 3D has to be less, then 4D, then 5D. But this is the first exception and this is the second exception. Second exception is zinc, cadmium and mercury, where mercury is supposed to have maximum but it is having minimum. Okay? That is the second exception here. And whenever I'll write exception, I'll write DM here. Okay? Diksha ma'am. Okay, DM means exception. Okay? Yes, everybody. Do let me know if these two things are clear to you. It's very, very important. Directly questions can be asked on the exceptions. The irony is they don't ask you questions on general trends. They ask you questions on exceptions. And exceptions are somewhere hidden in the graphs, in the tables. That's how these are hidden. Okay? Yes, everybody, this particular chart is clear to everybody or not? Let me see if there is any. I think there was some, yes, there was some question that we were about to do, but I skipped it, okay? So JEE Mains 2024 question, choose the correct option having all elements with D10 electronic configuration from the following. So you have to choose the one which is having D10 electronic configuration. So this is already ruled out, right? Okay. This is also ruled out. This is also ruled out. So can I say this is the answer? How these are ruled out? Okay. Here iron is not having, nickel is not having. Here iron is not having again. Chromium is not having. Cobalt is not having D10 electronic configuration. Here chromium is not having. Iron is not having. Nickel is not having. Platinum is having D10 configuration. 5s0, 4D10 electronic configuration. Here, all of them are having D10 electronic configuration, and that's why this is our answer. Okay? Yes, everybody? Very good, Raja, Supriya, Lakshay. Lakshay, what Lakshay is doing? Very good, Lakshay. Listen to the class, please. Very good. Yes, listen to the class. Okay? So, now who will answer the next question based on melting point? Shall we see that? Okay? Shall we see that? It is the correct option, the order of melting points of the pairs. Okay. Okay. So, everybody. Everybody who will answer me, I'm waiting for your answers in the. Should I give you poll here? Should I see that? Okay, 4 poll, is it possible or not? Let me see that. Wait a minute. I think. I'll have to. Wait a minute. Let's see how many of you are able to answer this. Let's see how many of you are able to answer this or not. Right? When it comes to poll, then ma'am's A, B, okay. Let's start it. Okay. I hope so you all have also liked the session. Let's see. How many of you will be able to answer this? Okay. ABCD, 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 ABCD. Think about this. That is directly from the graph. And this is not a very old question. This year, they have asked this, right? So that's why repetition happens. The same question is not repeated. Way it is asked can be repeated, or same question in a different form can be asked. Two things, right? Okay. So let's see. 57% of you have answered A. So you guys are suggesting that A is the correct answer, is it? Okay. Let's see that. Let's see that. If you're right or wrong. Okay, tell me from the graph here, right? Now you have the graph. Now answer me. Now you have the graph. Can you see technetium is less than this? Manganese is also is less than this. And this Re is also less than, is more than osmium, right? So out of this, technetium is less than, these are already ruled out. Manganese is less, this is also ruled out. So you have option C and D. See, even if you know about, even if you don't know about this thing, that is 5D, you know about 3D and 4D, right? I have specially mentioned 3D manganese has a dip, 4D technetium has a dip, right? So that means here you can see the problem. And here it was like this. That means answer is going to be D is the correct answer. And tell me how many of you answered D? Only 7% have answered D, right? So can you see this? It's not like they will ask you question from some other universe, right? They will not be like, okay, 2026 students will make new exceptions for these students. They will not do that. They will not make a new periodic table for you, right? Same thing will be there, right? Same time. It's just about memory. It's about remembering things. It's about revising things. Inorganic chemistry is marks is easy to score, right? Because new things they cannot form. They cannot even ask questions in different form. There is no calculations involved here, right? That's why I'm putting so much pressure on this, right? So next, guys, we have enthalpies of atomization, right? So who will tell me enthalpies of, ma'am, I answered before. Yes, Supriya, I saw that. You answered D. I saw that. So very good. So enthalpies of atomization. Now, what is atomization? Can you, like, if I don't give you any definition, from these three words, what you can understand: enthalpy, energy of atomization. Energy to make atoms, right? Yes, seriously, that is done. Now let's move to the next topic, that is enthalpy of atomization, right? Now, what you have here is, what you have? You have, let's say, H2, right? Gaseous. You want to convert it into atoms, okay? Now tell me the enthalpy that is required here is your enthalpy of atomization, or even the phase change. When you change something from solid to liquid, liquid to gas, that is also enthalpy of atomization. So basically, when you are breaking the bonds, right? You want to break the bonding and make some new atoms out of it, right? That is enthalpy. Not new atoms, but break it into atoms. That is called enthalpy of atomization, right? Now, can I say that enthalpy of atomization, now this is new important topic. Okay? I'll tell you about it, why it is new important topic, because in this 2025, they have asked questions based on this, right? We will also do it in detail, don't worry about that, but it's just that you have to remember the trend which is there in the table. And there is a weird exception to that, right? So that's why this DNF block students hates the most, because there are so many exceptions, and reason is only same, right? D shielding, F shielding, this and that. Too many exceptions are there, and I'm sorry, I can't do anything about it, right? I wish I could have, but I can't do, right? So enthalpy of atomization is dependent on bonding. If the bonding is very strong, then enthalpy of atomization will also be very strong. Now, bonding is directly dependent on metallic point. So, can I say, I am not saying exactly, I am saying somewhat. Somewhat enthalpy of atomization and metallic and melting point follows the same order. I am not saying exactly, I am saying somewhat. Okay? Yes, everybody. Ionization and atomization. See, ionization is you have an atom, you want to take out electron from the atom and you want to ionize it, convert it into cation or anion. Basically cation only. When you take the electron, you convert it into cation only. Atomization is you have this H, you are breaking this bond, right? Bond you are breaking. Let's say they are in the metallic bonding, you're breaking this bond, right? So that is called enthalpy of atomization. Okay? Yes. Now, the transition metals of second and third have now these are some exceptional things here. That is the transition metals of second and third series, right? What is the second series, everybody? Third series, 4D and 5D series, okay? Have greater enthalpy of atomization as corresponding to 3D. Now, can you tell me what is the reason behind that? I told you somewhat it will be same. We know that melting point is you have 3D, then this is in general. I am not talking about those two exceptions that we discussed. In general, I told you that this is the case. These are the two exceptions. In general, you have 3D, 4D and then 5D. This is general. Okay. And these are the exceptions for melting point. Now, talking about the same ground here, right? What we have is melting point has this strength. So similarly, we are saying that, yes. Similarly, we are saying that transition series, that is 4D and 5D, have, because they have greater melting point, so they will have greater enthalpy of atomization as well. Because they have greater melting point, they will have greater enthalpy of atomization as well. Because if metallic bonding is strong, melting point will be more. Melting point is more, so enthalpy of atomization will be more. Okay? Yes, everybody? Now, so this is the same thing. If you see, this is atomic number and this is your enthalpy of atomization here. Can you see this is kind of same thing? Kind of, I am not saying exactly, but kind of same thing that you are following here, right? Isn't it on the footprints of melting point only it is following? Not exactly same. Again, I am saying it's not exactly same. Kind of similar trend, right? Okay. Now, we'll also understand, wait a minute, I think enthalpy of, before doing atomic radii, we'll need to understand this as well. That is this thing here. Enthalpy of atomization. Now, this is your homework, right? What is your homework, everybody? Chapter, I have not completed the this lecture yet, right? It's not like I have completed the lecture, it's your homework, go bye-bye. No, right? This table you'll see in your NCRT. This is the enthalpy of atomization. From this, they have asked the question, right? This order, earlier we don't used to learn, but now we have to learn this as well. It's a very weird order, right? But I would advise you, this is given in your NCRT table, right? 3D series. In the comment section, every single student here, they will write down the order of 3D series enthalpy of atomization. Okay, you can take a screenshot here. You can take a screenshot. I'll just stand here, right? You can take a screenshot, guys. This is your homework. I am not even asking you to solve anything. All I am asking is this enthalpy you will write on your own, right? Let's say this is the minimum, right? So zinc has the minimum enthalpy of atomization, right? And you know, by that I also remember one more thing. That is your wait a minute. I also remember one more thing here regarding melting point only, right? If they ask you in 3D series, minimum melting point. Minimum melting point. Who will answer me this one? In zinc, memorize the graph. Yes, Divya, unfortunately, but you have to, right? You have to. You know, while teaching this block chemistry, I don't know why I get into this guilt, right? I feel very guilty about it, right? I don't know, even I have not made this. I just feel that, yeah, it's important because they want to know your memory also. But I just feel that why our education system can't go beyond this, right? Why we can't go beyond cramming? Why it's not only about like understanding the DNF block, understanding what is in the practical applications of DNF block, right? Why, right? So that is the sad part, but we can't do anything about it, right? All I can do is maximum that teach you what to learn, where to learn, make you understand as much as possible, right? Okay, because see, even I don't know, because these geniuses have made this so there might be some reason behind that only, right? Okay, wait a minute. Yes, scandium minimum. Yes, chalo, let's see this from here. Let's see this from here, right? It is not written over here. Let's see this from the table. Okay, let's see this from the table. From the data, we have to see the data here, right? The data of in melting point is here or not, we have to see that. Enthalpy is there. Electronic configuration, no, it is not there. I think I asked you the wrong question. I was supposed to ask you not the melting point. Minimum melting point nahi. Minimum enthalpy of atomization, right? That is in your data. Okay. So from the data, they can ask you minimum enthalpy of atomization in 3D. Okay. That is going to be zinc. If you talk about maximum, that will be for vanadium. Okay. So wait a minute. Let me just show you that here. Right. Maximum is, can you see this? Maximum is for this vanadium. So this is having maximum, this is having minimum. This is having minimum. Okay. Maximum, minimum, you should definitely know. And I would suggest you to remember this as it is. And that's why I'm asking you to write it down in the comment section after the class. And tomorrow I'll see how many of you actually do this. Okay. Yes, everybody. Now, let's see in the series why enthalpy of atomization of zinc is lowest. Anybody? Why zinc enthalpy of atomization is lowest? You were giving the right reason when you were talking about scandium. You were giving me the right reason, guys. You were giving me the exactly right reason behind that. Same reason is behind this. Zinc is having, ma'am, what? 4s2 3d10. Ma'am, it has no unpaired electron. No unpaired electron, not even one unpaired electron. Even in the excited state, there is no unpaired electron. That means it is going to have minimum enthalpy of atomization. So it will have no unpaired electron, even in the excited state. No unpaired electron. So that's the reason why we will say that it is going to have minimum enthalpy of atomization. There is no unpaired electron to have bonding with someone. In a circle, everyone is committed. No outer person is coming there in their circle. Right? So, minimum enthalpy of atomization it will have. Right? Okay. Now let's talk about atomic radii, ionization, enthalpy. And these two, after these two things, will the class will end. Okay. Oxidation number, standard electrode potential, then small properties that we'll do in the next class. Okay, because atomic radius and ionization enthalpy is quite easy, but yes, very important for you to remember. Right? In this, very good. Yes, absolutely right. Okay. So, if you see this atomic radii, now this you must have studied in periodic classification as well, but I am assuming that you have not studied it. Okay, I am assuming that thing. Now, first is comparison with 3D, 4D and 5D. Then there is throughout 3D what happens. Okay, so let's talk about throughout 3D what happens firstly, right? Generally, the atomic radii of d-block in the series decrease with increase in atomic number, but decrease in atomic number very small. Okay. Now, what is this, ma'am? It is decreasing. It is becoming constant. It is increasing. It's like this. It's a U kind of curve that will be formed here. Can you see that here? It's a U kind of curve that will be formed here. Okay. Let's talk about that why we have formed this particular thing here. Right? Okay. From the graph only so many things will be clear. So there's a competition between two effects. One is screening effect. One is Z effective. So now first you need to tell me what is screening effect, what is Z effective. Right? Okay, everybody, what is screening effect? Everybody here, come on, what is screening effect? Someone is sitting here, right? In the nucleus, there is protons, positive charge attracting the electron, outermost electron attraction. It's like your parents who are like, where is my kid? Are you there with your friend? Come back home fast, right? So that is inside your nucleus, inside the home. Your parents are. They're calling you. They worry about you, right? Electron is revolving outside. They're attracting it. Now, some siblings are good. They're like, don't worry, you go out. I'll take care of the situation at home. Some siblings are like, how dare you go out? Now I'll take care of the situation at home. I'll tell parents about this. Don't worry. I'll do all the spice and all that I'll do. Don't worry. Everything you leave it on me. I know that how to have that fire, right, in the home, right? So that your some siblings are like that. So that is the shielding effect, right? Some siblings are like they want to protect you, right? They are like, okay, I'll protect my younger brother, sister, elder brother, sister, right? Some siblings are like, I don't want to protect you. I'll make your life more hell. I'll see what you do, huh? I'll see. Especially these brothers, they do all these things, you know? Brothers and sisters, they fight a lot, right? So shielding effect is basically that how this nucleus and this outermost electron, how the inner core electrons in between, they protect the outermost electron from the nucleus. That is your shielding effect. Shielding effect is how the outermost electron is protected by the inner core electrons from the nucleus. Okay, that is your screening effect, shielding effect. Okay, next is what is Z effective? Now, earlier nuclear charge is how much charge nucleus is putting on the outermost electron. You have 5 proton, it's pulling it from the 5 proton power. It has 7 proton, it is pulling it from the 7 proton power, right? Now, power it has of 5 proton, but there are inner core electrons also. Got it, na? This is the nucleus. This is the inner core electron. This is the outermost electron, right? These things are shielding. These inner core electrons are shielding it, right? Now, this shielding is the shielding effect. How much protectiveness is there, right? And how much charge this nucleus, this positive charge is able to put on this electron. it had 7 proton, let's say, but it had some 3.5 or 1.5 something is the shielding effect. Now, because of this shielding, because of this protection, these electrons will not be attracted with that much efficiency, right? So that is the reason what we will say that, buddy, you are now not winning, right? So two things are competing. When the shielding effect is very high, Z effective is less. Okay? Nuclear charge decreases. Understood this part, everybody? When the shielding effect is high, too many mosquitoes here. I think you guys are praying, ma'am. Please, mosquitoes, you bite, ma'am, so that ma'am can end the class. Oh my God. So, understood this? Two things are fighting, effective, Z effective and shielding effect. Now, what is happening here? Firstly, the size is decreasing. Size is decreasing. What is the reason behind that? Z effective is increasing, right? Shielding is not good. The sibling is not able to shield you. Parents are even more strict now. They're getting more strict, right? So outermost electron is getting attracted by the shielding is not good. Outermost electron is getting attracted. Shielding is not good, no, right? So that is the reason it is decreasing. In Fe, Ni, iron, cobalt, nickel, it will become constant because they are fighting to next level. There is tug of war situation. Shielding effect and Z effective are like fighting with each other. They both are giving equal potential to each other, right? So that is the reason it's always constant, right? Now next is it is increasing here. Now how come it is increasing here? Now it is decreasing, it has become constant. Now it is increasing because, can you tell me it in the chat box, which thing is increasing here? Here you have Z effective is increasing. Now it is Z effective is increasing, that is why the size is decreasing. If the size is increasing, that means now shielding is more. That's why size is increasing. Shielding increases. Okay? Right, everybody? Shielding is more, that's why size is going to increase in this case. So that's how Z effective decreases, constant increases, decreases, constant increases. That's how it is going to go. Right, everybody? Okay, yes. Right? Shielding increases. Okay, shielding increases in this case. Shielding increases means that it is able to protect, the size will increase. Okay? So when your sibling is protecting you, you will be able to go out, right? When the sibling is not protecting you, won't be able to go out. Going out is that, okay, the parameter is increasing, right? You are moving, like you are going to Ooty, you are going to Goa, because your sibling is very like, okay, let him or her go. Why you are ruining his or her life, right? So it's like that, right? So see, things depends on your siblings a lot, right? So now, can you tell me what you can predict here, right? Now it is decreasing, constant increasing, constant increasing, constant increasing. Now the size down the group is increasing or decreasing. Down the group, size is increasing or decreasing, everybody? Yes. As you go down the group, what happens? Size of the 3D, 4D, 5D series. Can't you see? This is 3D. Okay, I'll just mention this here. This is 3D, this is 4D, this is 5D. Now you tell me, is that increasing? Isn't it increasing? Isn't it increasing, everybody? Down the group, the size is increasing. Okay, 3D, 4D and 5D. This is very, very important. I'll just tell you the full process about it, right? 3D, 4D and 5D series, it's like this, 3D, 4D and then 5D series. Now the question is that why this happens, okay? Because down the group here, right, size is increasing here, right? This is what happens throughout also. Down the group size always increases, right? Here the reason is also lanthanoid contraction. That's why I'm saying that things are very, very interesting here because of lanthanoid contraction as well. I'll tell you how things are very, very interesting here because of lanthanoid contraction as well. So let's talk about this lanthanoid contraction. Okay. For that, you have to visualize this again. Okay. For that, you have to visualize this table again. Okay. From this table only, I'll teach you what is lanthanoid contraction. This is where you have lanthanoids. This is where you have actinoids. Okay. So now I'm talking about lanthanoids only, right? This is where you have lanthanoids. Okay. Till here you have 3D, 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 3D. Here you have 4D, 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 4D. Here you have 5D. Suddenly in hafnium, here you have 4F, 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 4F. And here also you have the filling of 4F. Understood? Now can you see, until here, there was only 3D orbital which was being filled, right? Now here you have 4F, 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 4F. Why? Because from cerium you have 4F, 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 4F till lutetium. This one is lutetium. This is cerium here, right? Cerium to lutetium you have 4F, which is being filled. After here it is how it is filled. That also I'll tell you. It will start from 4F 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. Right? F orbital has only 14 electrons that can be filled here. Isn't it? Now, that means after this, always it will going to 4F, 14, 4F, 14, 4F, 14, 4F, 14, 4F, 14, and so on till here. Right? Even after that, it will be 4F, 14, 14, 14, 14 will be here. Right? Now, can we see that 4F14 is there, right? 4F14 is suddenly added to this position. Lanthanum is not having 4F14. This is having 4F14. So, can I say that suddenly 4F14 F block element is F block orbital is introduced, and we know that shielding effect is SPD, and then you have F. F is poorest in shielding. Such a bad friend he is. Why? He is like not protecting you. He is telling your parents that right now you are at a movie hall. Right now you are going out. Right? Right now you are like maybe in Goa or wherever you are. Right? In your dreams, I know. Right? So, your sibling or your best friend is not a good shielding effect. That means they are not able to protect you. This is the proton, this is the outermost electron, and in between you have inner core electrons. Now these inner core electrons are not able to shield you, right? So that's why the size will decrease, because these inner core electrons are not effective. Nucleus wants to attract the outermost electron because the inner core electrons are useless, right? That's why it is able to attract it. That is called contraction. That is called lanthanoid contraction. Why? Because this happens because of the poor shielding effect of this 4F orbital. Okay? Yes, everybody? Ma'am, is it necessary to remember F block configuration? Kavashi, yes, it is important, but no, it's not Kavashi, it's Vamsi. Vamsi, yes, it's very, very important to remember that, right? I'll also tell you which to remember, which not to remember. That I'll tell you when you start doing lanthanoids, okay? For now, just tell me if lanthanoid contraction is clear to all of you or not. Now, because of this lanthanoid contraction, some things will happen here. So what I'm going to do, I'm just going to copy paste this here so that we don't have to again and again and again and again go here. Okay. So what is this lanthanoid contraction? The atomic radii of elements in the second and third transition elements are nearly same. Second and third transition means you have 4D and 5D series is nearly same. 4D and 5D series is nearly same. So can you see this here? This is your 3D series. This is 4D series. This is 5D series. Now, in this particular way, what is happening? Lanthanoid contraction is happening. The size which what it was supposed to be, it is decreasing because of poor shielding effect of 4f orbitals. That is the reason this particular 5D series will have less size as we were thinking, right? So that's why it will be comparable with 4D. So that's why very famous question is why hafnium and zirconium has, this is zirconium, this is hafnium, have same size, right? These all are having the same size, right? All of these are having the similar size, right? But you know, this is only applied after group 4 to 12. This is only applied from group 4 to 12. Can we see this in the graph, ma'am? Yes, you can see this. You can actually visualize this in the graph as well, right? From this, can you see there is very large gap, right? Over here, 4D and 5D, can you see this has a similar graph, like they're almost overlapping with each other. Can you see that? So 3D series is having less size, then you have 4D, which is approximately similar to 5D. The reason being lanthanoid contraction. The reason being lanthanoid contraction. Lanthanoid contraction. Okay? Yes? Yes? Yes, everybody? Natik, please don't spam. Nothing is going to happen, right? So, is that clear, everybody? Don't spam, students, don't spam, okay? Don't spam in the chat box, right? Don't do it, right? Everybody is quite serious about, because see, 5 months are left. Why we are wasting our time here, right? Let's not do that. Let's utilize as much time as possible, right? Because very less time we have, right? So we need to utilize every single day, right? Okay. Now, can I say that I'll write it in a different way now. I'll write it in a different way now, right? Okay. No. Okay. Let's write it like this. You have 3D is then 4D, then you have 5D. This is from group number 3 to 4. Okay? Till 3 to 4 you have this thing. 3 to 4. Now if you talk about group 4 to, this is specially mentioned, 4 to 12, you have 3D, then you have 4D, which is approximately similar to 5D. Now, can you tell me the reason behind that? Let me see. How many of you are able to find the difference here? Why it is so? Why it is so, students? Can you tell me the reason behind that? Why it is so? Reason is because if you see this on the table, right? This is the table. If you see this, this is your 3D, 4D and 5D series, right? Here you have the lanthanum. Here you have the addition of 4F. Before 3 to 4, there is no as such jump here, right? So that's why if you talk about third, in fact, it should not be written as 3 to 4. It should be written as group number 3. Okay? It should be simply written as group number 3. Group number 3, actually, this should be more accurate. This should be not, it should not be like this. It should be like this. This is 3D. There should be large gap here. Then it should collide. It should like be parallel to each other. It should be like this. Here it should still be a large gap. Not very large, but still a sufficient gap should be there, right? If you talk about the like proper graph here, right? So now in group number 3, there is no lanthanoid contraction. Scandium, ytterbium, lanthanum, there is they don't have 4F, right? Even lanthanum is not having 4F. That's why in group number 3, it is following the same thing. But as you move to 4 to 12, now you have, what you have now? You have 4F 14 orbitals, right? 4F 14 electrons. You have 4F orbitals here. Lanthanoid contraction will be there. That's why 4D, 5D will be almost similar in case of Group number 4 to 12. Is that clear to everybody why I have specified this thing here? Right? Okay. For maths, it's already done, and for physics, sir is going to do that, right? For maths, it's already done. Okay? Yes. So everybody, now let's move to the next part here, that is exception. This is the exception that you have, right? Now, can you tell me why this exception is there? Because no 4f orbitals, no lanthanoid or actinoid contraction. No lanthanoid contraction or even actinoid contraction that we will study in actinoids. Okay. Just like you have 4f, similar way you have 5f also. Okay. That is actinoid contraction. So now ionic radii is the trend followed by ionic radii is same as that of followed by atomic radii. Ionic radii of transition metal atoms are different in different oxidation states. Right? The ionic radii of transition elements are same than those of representative elements belonging to the same period. So they are saying that it depends upon the oxidation state of the metal, what will be the ionic radii. Okay, so ionic radii in detail, we have already done this in periodic classification, not that much will be there here. Ionic radii is more important in periodic classification than here. Okay, yes, here we will just talk about this in the similar notes only. But in ionic radii, isoelectronic species, these are important when you talk about periodic classification. Okay. Now, next is the decrease in metallic radiation. Now, what is density? Anybody in the chat box? What is density? What is density, guys? Density is equals to mass by volume, right? Mass by volume. Now, if you see this here, right, what is happening? The decrease in metallic radius with increase in atomic mass, decrease in metallic radius with increase in atomic mass. As the atomic mass is increasing, atomic radius is decreasing, right? Increase in density. Now, why they are saying this? See, as atomic mass is increasing, okay? We are saying that we are taking some example here, right? Because every single trend is exception here, right? That's why I'm telling you that density, just relax for some time. I'll tell you, just general overview we are saying. If your mass is increasing and then radius is decreasing at that point, right? Mass is increasing and radius is decreasing. In that case, radius decreases means volume is also going to increase here, right? Okay. So, it should be volume is going to decrease. Okay? Yes. Now, volume is decreasing because the radius is decreasing. Volume is equals to 4 by 3 pi r cube. Okay? So, radius is decreasing, volume will decrease. So, in that matter, this density is going to increase because this decreases means this will increase. This increases means this should increase. That should be there, isn't it? If I am assuming that decrease in metallic radius, obviously it will increase the volume. With increase in atomic mass, and atomic mass, this condition they have given us, that mass is increasing, radius is decreasing. So volume is decreasing, density should increase, right? Increase in density. Thus, titanium to copper, there is increase in the density, right? Titanium to copper, if you talk about this thing here, right? This thing here, this to this, they are saying there is increase in the density. But ma'am, what happens here? What happens here? That is the main cause, okay? That is the exception that we are going to talk about, right? Exception is density of zinc is less than density of copper. Can you tell me why? Can you tell me why? We have just read it somewhere. Okay, let me just show you the atomic radii, where it was. No, not atomic radii. Hmm, wait a minute. Density of zinc. Because zinc size is less than this. There is exception in this, okay? So why there is this exception, that I have just taught you somewhere. Wait a minute, let me just see that. I think so I have taught you that, right? Because this is the most important part here, okay? Like zinc has minimum enthalpy of atomization, and then melting point also we saw for zinc, where we saw this is copper and zinc. Ionization we talked about, or what? No, we have not talked about that actually. है ना? Atomic radii only we talked about. Okay. So, if you talk about this particular thing here, right? If you talk about this particular thing here, then overall here what will happen is similar thing, because you have 3D series, right? Now here we know that what is happening. Radius is decreasing in this case, okay? Because size is decreasing in this case, right? Along the period, size is decreasing, and the mass is obviously increasing because the number of electron proton are increasing, right? So with this formula, the density should increase here. But in reality, the density, if you see, it was over here, right? Yes. Density, 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 yes, it was here. Okay. So if you see this density, it is going like this. It is increasing, 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 increasing. But suddenly it drops from copper to zinc. Okay. From copper to zinc, it will suddenly drop here, right? What is the reason behind that? Because here you have like fully filled d orbital, like in 4s also, in 3D also, in excited state also, right? So that is the reason its density is going to decrease here. Its mass is increasing, right? Its radius will slightly be on a different side. That's the reason here. If you see this here, here I told you. Where is that? Where is that? Where is that? I have just drawn it. Yes. If you see this here, okay? This is slightly increasing in this case. Copper to zinc, okay? So why you have copper density should be less than zinc? This was supposed to be like this, right? It was supposed to be like this. Copper should be less than zinc, right? But in reality, because of the exception in the size, in the radius, we know that density is equals to mass by volume. See, from copper to zinc, we know that mass is definitely increasing, but the radius is also increasing, so volume is also increasing. The increase in volume is so high that it decreases the density. Okay, everybody got it or not? Yes, everybody, tell me if that is clear to all of you or not, right? Okay, why you have density of zinc, I'll just write it here as well, because density is equals to mass by volume, and mass is definitely increasing here, but we know that volume is decreasing or increasing. This is mass by volume, guys. This mass is definitely increasing. Atomic number is increasing, mass is increasing, right? But radius is increasing, so volume is also increasing. When this is increasing, this should increase. But because this volume is also increasing, so this is automatically decreasing. So that is the reason you have density of zinc is less than copper. It's very, very, very important. Okay. Yes, everybody. Now this is your JEE Mains 2021 question that is based on density, right? Based on direct density. Okay. Yes, everybody. Everyone, I'm waiting for your answers in the chat box. Let me see. Let me put a poll also here. Let us see who will answer. Okay. Let's see who will answer. Let's see A or B. Let's see if there is, why I have this habit of putting polls, because in the Sigma batch we do the same, right? Here I can't see because YouTube doesn't work like that. Here I can't see that like which student is like on the top, like which student is answering in 2 seconds, 3 seconds, and which of the following, which of you are actually answering right or wrong, that I don't know. I can't set a timer here because all of that I can do there. So that makes me really happy. So that's why I'm putting the poll here as well, so that you can also feel the same thing, right? So, enemy, I have provided the schedule. I have actually provided the planner, schedule, everything. I think the 5th time I'm saying this in this class. Students, I have already provided it, right? I'll also show you that in the channel, right? So what is the correct order of the following elements with respect to your density, right? Now, we know that density of zinc, copper should be greater than zinc. So this should not be correct. Copper is copper is greater than zinc, okay? Here copper is greater than zinc, okay? Here copper is greater than zinc. Okay. Now, everybody, it should increase, then suddenly drops. Increase. Okay, so it is piconikujan. So 62% of you have answered it correctly, right? Where is iron? Iron is over here, right? Where is chromium? Chromium is here. Where is zinc? Zinc is here. Copper is here. Then you have cobalt is here, right? So now if you see, it should be chromium, iron, cobalt, then copper, then zinc is less, okay? Chromium, iron, cobalt, copper, chromium, iron, cobalt, copper, it's not so less, okay? Chromium, iron, this is obviously wrong. Now this and this can be the correct answer. Here zinc is intermediate between cobalt and chromium, and here it is less, right? So if you see this from the data here, right? This is your Sakti worker, right? And this is 7.1. Can you see that is 7.19? Wait a minute. Piconikujan. So you should also know to what extent it has decreased. Can you see this is 7.19, this is 7.1. So this is even less than chromium, right? This is what we wanted to know, that it is even less than chromium, right? Okay, from the data, because they will not give you the data here. It is even less than chromium here, right everybody? So answer will be C is the correct answer. This is from the experimental data that we have. Okay, from the data in book. Ma'am, I am checking the data on Google. Doesn't matter. I am checking the data on ChatGPT. Doesn't matter. What is in your NCERT is what matters here for your exam, right? For your exam. What is written in your NCERT will be taken as correct. Okay. Yes, Natik, I am teaching 11th and currently structure of atom is going on there. Right? Okay. Now let's talk about ionization enthalpy, and after that we shall end the lecture. Okay. Yes, everybody. Now let's do this ionization enthalpy. Right? Now, what is the trend of group number 3? That is very important because there is some unique trend that it follows. Okay. So, Sakti Kar Man Pico Niku Jan. Okay. Right. Now tell me one thing. Along the period, right, what should happen? In general, what happens? Ionization energy decreases or increases along the period. In general, ionization enthalpy, it increases or decreases. Along the period, size will, in general, size decreases, right? So ionization enthalpy should increase in general, right? So that means, can I just write it like this? Beta, trust me, it is difficult to learn all these things. So I'm giving you as much as tricks as possible. Right? So how do you remember this? How do you remember this? V ko ni. V ko ni. In front of V, change the sign. In front of ko, change the sign. In front of ni, change the sign. Ma'am, what is the sign that we have to change? Let's see that. Ma'am, what is the sign that we have to change? It's going like this, it will be like this. Okay? It's going like this, it will be like this. Firstly, it is increasing, then decreasing, then increasing, then increasing, then decreasing, then increasing. Okay? See, that's why I told you this trick. Generally, it is increasing, but in front of V, ko, ni, you change the sign. Okay? In front of V, ko, ni, you change the sign. Okay? That's only way you can remember this. It's a very weird trend it has. Right? So, firstly, it increases, then it decreases, then it increases, then decreases, then increases, right? So, best way is to remember it like this. Generally, it increases in front of V, ko, ni, change the sign. Okay? Yes, everybody? Right? Okay, easy to remember is STC, MICNCZ. Okay, Bhuvnesh, good, very good. Right, everyone has their own way of learning these mnemonics, right? So I think that's it, right? Now ionization enthalpy, you can see this here, right? Wait a minute, it should be like this. Okay, table is a little bit tilted, right? So as you can see, it increases, it decreases. I'll just write it here. It increases, then it decreases, then it increases, then it increases, then it increases, then it decreases, it decreases, it increases, it increases. Okay? Wait a minute. Here it is. It increases, it decreases, it decreases, it increases, it increases. Okay? But you can't remember it like that. Okay? Yes, everybody? Okay, Anime, perfect. I'm happy that you guys will be regular in the classes, right? Because this is the high time that you should be, right? Okay, so now some important things we are going to talk about, right? Okay. Yes, everybody, some important things. Let's talk about that, right? That is firstly this exception here, right? So in ionization enthalpy, there are some exceptions here. Firstly, you should remember what exactly happens in trend for 4th to 12th group. Yes, everybody. Yes, everyone. Do let me know what exactly happens here. Right, everybody? Wait a minute. Okay, so tell me here till where should I write? Okay, till group number 3, I'll write it here only. Right, two cases we have. Right, till group number 3, what happens? Right, from group 4 to 12, what happens? Any one of you in the chat box? Any one of you in the chat box? Yes. Yeah, it's the starting, guys. It's the starting, right? It's the starting. I am showing you. See, every single topic I have shown you previous year questions, so you can yourself analyze, right? It's not enough, but I am teaching you. I have not even completed the chapter yet, right? So group number 3 is simple. If atomic radius is increasing, we were saying, right? So this is going to decrease, right? Right? This is going to happen here, right, everyone? Right, everyone? Yes or no? Is this what we're going to do? Right? Yes. Now tell me what is going to happen here. This is 3D. If you see that 3D and 4D, right? There is no as such difference here, right? So there is no lanthanoid contraction, so it will definitely decrease. Simple, general. This is general. But from 4D to 5D, the size was becoming equal. The atomic radius was becoming equal, right? Atomic radius was becoming almost equal. So that is the reason, because of the lanthanoid contraction, here what will happen? It will be opposite. 4D will have less as compared to 5D. Because 5D, what it was supposed to be, its size has decreased, right? That is the reason its ionization enthalpy has increased, because of the interference of 4f electrons. It means lanthanoid contraction. Lanthanoid contraction. Students, tell me if that is clear to all of you or not. Right? Okay? Yes, everybody? Okay? Right? Now, this lanthanoid contraction has decreased to that extent that 5D has maximum. Then you have 4D. Then you have 3D. Then you have 4D. This is the weird ionization enthalpy trend that you have. Okay? Because of lanthanoid contraction. Yes, students? Okay? Yes, everybody? See, on YouTube, if you're saying, then you can contribute, right? There will be option for that, right? If you feel like, you can definitely do that, right? And you can like, share and subscribe to the channel, share this, that will be your contribution to our YouTube channel. And if you talk about a proper batch for that, right, then for batch, definitely you have to pay the minimal amount, that is 4,999, right? Okay? Yes. So, tell me, students, if that is clear to everyone of you or not. Okay? So, let's talk about this exception here. Now, ma'am, is there any other exception? Yes. There are these 3 exceptions. Okay, I am so sorry that there are so many exceptions, but what do I do, guys? Right? I can only tell you these exceptions. Even this has exception. Even this trend has this exception, that is you have in this, and in this. You can see VC Workoni, Wakarni, or you can like see whatever, VCN, you can say VCN, you have the exception. Okay? Yes, everybody? Okay, everyone? Okay? So, what exactly I am telling you, I'll again explain that, right? See, group number 3, because of there is no lanthanoid contraction, so it is going to be normal. 3D maximum, 4D, then 5D as general. Now, group number 4 to 12, because of lanthanoid contraction, 5D will have more as compared to 4D. In every single group, it is going to behave like that. That means every single group except for vanadium, except for vanadium group, chromium and nickel. Except for these 3, you will have 5D will be maximum, then 3D, then you will have 4D, right? But in this case, what you will have? Everybody, in this case, what you will have? mean I am having issue in inorganic chemistry. That's why I am here, guys. That's why I am here, right? So here what will happen? This is V NBTA. Okay, this is CrMoW. This is NiPdPt. Okay, can you see this here? That's a total exception that you have here. Okay, everybody? Okay, everybody, tell me if that is clear or not. Is that clear? No, we have, you have, oops. Is it 10:30? OMG, I didn't see it only that it's 10:30. This is what happens when I'm in the flow. I didn't know that it's 10:30. It's the last thing that we are doing, okay? So you can do your homework after that. Firstly, tell me if this thing is clear, because this now I have doubt that I don't know if you're able to understand this or not, right? This is in general, right? This is because of lanthanoid contraction, but here also you have this exception that is opposite of this thing, right? Okay, that is exception. Why so? Don't get into that. Just know that these are the exceptions. Okay, yes, everybody. Right, this is for 3D series that I told you. The first ionization enthalpy, now it's a very important thing that I'm going to tell you here. Of 5D element are higher as compared to those of 3D and 4D. This is because of weak shielding effect that I have already told you, lanthanoid contraction, right? Okay, along the period. This also, students, we have already discussed, right? Magnetic, we are not going to discuss here, right? Now, just 2-3 things I'm left with. Copper, zinc 3 positive and copper 3 positive does not exist. Okay, there are 3-4 questions that I have. Let me just show you those 3-4 questions here. Just give me a second. Right? Okay. So that is based on the ionization enthalpy. Okay, so I'll tell you one by one. Okay, so one by one we'll talk about that. First question is, this is based on simple electronic configuration, how they can ask you question. Okay, so first question they can ask you is, why copper, no, let's talk about manganese, or let's say, wait a minute. Okay, manganese has very high third ionization enthalpy. Can you tell me the reason here? Whenever these kind of questions are there, how you will answer? Manganese, you will say, ma'am, manganese is 4s2 3d5. Okay, electronic configuration you have to be pro in. After losing one electron, it will become 4s1 3d5. The electron is always taken out first from 4s. Okay, now after losing one more electron, it will become 4s0 3d5. Now this is your IE1 that is required. This is IE2 that is required. The energy required here will be IE3. But this is a stable configuration, right? So to take out electron from stable configuration, it's very difficult. That's why IE3 is very high. Okay? That's why IE3 is very high. Now these are the simplest kind of questions from based on ionization enthalpy. Same thing you can see here as well. Same thing, I'll write down some questions here. In the similar way, the questions can be chromium. Chromium has very high IE2. Can you tell me why? Because chromium is 4s1 3d5. You take out one electron, it will be converted to 3d5. When you take out second electron, you are taking it out from a stable configuration, which is very difficult, right? So that's why second ionization enthalpy is very high. On the similar ground, we have one more. That is, you have copper. Second ionization, second IE is very high. Similar, same thing, because copper also is 4s1 3d10. So when you take out one electron, you have 3d10. And to take out one electron from this 3d10 is very difficult, right? And on the similar grounds, you have one more question, that is zinc 3 positive is impossible. Can you tell me why? Similar thing. You have zinc is, even copper 3 positive for that matter. Okay. You can also write it here, and copper 3 positive. You must have never heard of zinc 3 positive, copper 3 positive. It's very difficult, right? So I'll just write it here, zinc 3 positive, right? Because copper positive, copper 2 positive also have a different way of looking at it, right? So zinc 2 positive, zinc is 4s2 3d10. You take out one electron, it will become 4s1 3d10. You take out one more electron, it will become 3d10. Then can you take electron from here? This is IE1. This is IE1. This is IE2. This is IE3. ठीक है? नहीं. Sorry. This is IE1. This is IE2. And now to take out electron from this stable configuration, it's very difficult. So that's why IE3 here will be very, very high. That's why zinc 3 positive is not possible. Okay, everybody understood? Ma'am, can I get today's lecture notes? Definitely you can get it, and where you will get it is in the description box, guys. And you have your homework as well here, right? What is the homework, guys? Everybody do let me know what is the homework. What is the homework? What I told you? To write down the order of enthalpy of atomization in the comment section. Okay, so you have this here. This is what you have to write down. The trend, or you can say the order of enthalpy of atomization in the comment section yourself. Don't copy paste. Please don't do that. Write it yourself, right? This will help you only. This is not going to help me. You will answer that in the exam, right? So when you write something, when you draw, when you try to analyze the pattern yourself, that will stay in your head, right? That's why I'm telling you. I could have also written it, right? But why I'm telling you? Because that will stay in your head. Okay. So that was about today, and I want all of you to write the order of enthalpy of atomization in the comment section, whether you're watching this on recorded version or on the live version. I want all of you to write it down in the comment section. Yes? Okay. Yes. So guys, that's it for today. And here we have, wait a minute, that is, yes. So here we have JEE Sigma batch that every one of you were asking, right? So guys, this is the batch which is for 12th and dropper students, where we have like all the live classes are there in the batch. And not only the live classes, quizzes, just like here. I can't hear the different part is, difficult part is that I can't see that how many of you are answering it correctly. What are the time? I can't give you 30, 40, 50 seconds, 2 minutes, right? But there in the batch, we have proper time, right, for the quizzes as well. There are leaderboards, right? Then after class also DPPs are provided to you. And not only the DPPs, right? Tattva modules are provided to you. For your revision, after every 15 days, that means after in every 2 weeks, you have your mock test. That is like there, right? Just like I'll show you here, right? Now, you want to see that what exactly is happening here in the batch. So you will see there is a group of batch, right? There is a there is group of Sigma JEE 2026 aspirants. If you're able to see this, this is already the test is there, right? That what is the test for chemistry part, for mathematics part, for what is the time here, right? So everything is there. They have their test on 27th, right? And they already have given so many tests there, right? So all these things that already we have informed them today, so that they have 1 week to prepare themselves from the mock test that is going to happen on 27th, right? So that's how the batch goes, right? Students then practice from Tattva books, right? There are doubt sessions that are taken on Telegram group. There are quizzes. Everything is going on there, right? And it's an excellent batch, guys. And if you also want quick revision cards that are also available there, you can check that out here. That if you just want simple Sigma batch, all the features will be there that I have just told you, right? Along with the test series, right? Then that is for 4999. Now, if you're someone who wants these QR cards as well for your revision, now there are like plenty of QR cards here. This I have just a set of chemistry. Similarly, you will have mathematics, you will have physics also, right? So like totally, I think I'm totally burned out. So this is for physics and chemistry and mathematics, you have it. And Tattva JEE 11th and 12th books also be there. Now the question might be, ma'am, is it not available here? It is available there as well. It's just that here it is the hard copy, it is the soft copy available here. Right, here books will be delivered at your home. Right, then you have, yes, these two things in the hard copy version, that is for 9,999. Okay, yes, everybody. So that's it for today. Now I'll be waiting for your comment in the comment section regarding the order of enthalpy of atomization. Okay, so that's it, guys. Okay, then bye bye. Take care. See you all in the next class. Bye bye.